Welcome to the project demonstration of floating dual axis solar tracking system. So the main application of this project is this system can float on the water, and also defaultly it will check with the sun direction using these 4 LDR sensors. So east to west these 2 sensors, and north to south deviation these 2 sensors can be used, and based on the sun position the system will place this solar panel perpendicular to the sunlight by using the 2 DC motors, one DC motor for east to west deviation rotation purpose, and another third DC motor, second DC motor we placed over here. So you can see that. So that is a DC motor used for north to south deviation purpose, and these 2 DC motors are 12 volt 1 ampere DC motors. The rating of the speed is 3.5 RPM rating, and these 2 will be controlled by using this PIC microcontroller based on this L298 motor driver, and based on the LDR's inputs to the microcontroller, the system will control the direction of these DC motors using this L298 motor driver, and we place the 3 limit switches to limit the rotation of these DC motors. So this considered as a east side, and this one is a west side, and this is a north deviation limit switch. Whenever we switch on the gauge, this DC motor will rotate the solar panel till it touches this limit switch, and the next this motor will be rotated still touching of this limit switch, and then it will follow the lighting availability on this LDR sensors. So let us see the demonstration. And also we are using a 12 volt 1 amp DC battery pack which is a rechargeable battery pack. So before demonstration we are going to provide this charging circuits and place the battery on the shown B slots, and you can on the power supply to the transformer 230 volts AC inputs. Then there we can see the light indication of on the charger, and which will take around 4 to 5 hours to be fully charged. Right, so as we discussed before demonstration, keep the battery under full charge. Right, so there you can see the light indication on this charger once we provide the 230 volts AC input to this. So it will take, as we discussed, 4 to 5 hours to be fully charged till the duration, which will keep the battery under full charge, and then you can disconnect this. And here we can see this is the main on off switch for the system. Okay, now let us see the demonstration. Just I'm keeping on. So above is on, below is off, above on, and then the light will be on indicated. Now for demonstration, just I'm showing this torch light for sunlight presentation. So if I stop the movement of this mobile phone, that stops moving. So coming to the south deviation. So once the sunlight was equal on the both LDRs, then it stops moving. Right, okay. So the movement will be limited based on the limit switch. So once it reaches the dead end, then the limit switch will inform to the microcontroller. So we have reached the dead limit, then automatically the system will stop rotation and it will bring it back to the east side. So here we have interfaced these 4 LDR sensors at A0, A1, A2, A3. So 4 LDRs for the 4 pins, and the next L2938 C0, L298 at C0, C1, C2, C3 pins. So once it touches the limit switch, then automatically backs to the initial, and then the below motor will rotates. Right, so it's a continuous process. Right, so again it will back to the normal working mode. So it's a continuous process. So only the main thing is, while we demonstrating the project, we should take care of the limit switch positions and the battery under fully charged before demonstration of this project. Thank you.